Welcome to this lesson on conservation of energy, focusing on energy transformations in isolated systems. This is part of the energy series. Today, we will explore one of the most fundamental principles in physics, how energy behaves and changes form while its total amount remains unchanged. Understanding this concept is crucial for explaining countless natural phenomena and technological applications we encounter every day. Let's begin with the fundamental principle of energy conservation. This principle states that energy cannot be created or destroyed, only transformed from one form to another. Think of energy as something that never appears out of nothing and never completely disappears. Instead, it continuously changes its form. For example, when you turn on a light bulb, electrical energy transforms into light and heat energy, but the total amount of energy remains the same throughout this process. To fully understand energy conservation, we need to know what an isolated system is. An isolated system is a system with no exchange of matter or energy with its surroundings. This means no energy enters or leaves the system. Think of it as a perfectly sealed container where nothing goes in or out. While perfectly isolated systems are theoretical and don't truly exist in nature, they provide us with an ideal framework for understanding how energy behaves without external interference. Here is the core law of energy conservation. Total energy in an isolated system remains constant. This is the heart of everything we're discussing today. No matter what transformations occur within the system, no matter how energy changes from one form to another, the sum of all energies always stays exactly the same. This constancy is what makes energy conservation such a powerful and reliable principle in physics. We can express this law mathematically. E total equals constant. This simple equation tells us that the sum of all energies in the system never changes. Whether we're looking at kinetic energy, potential energy, thermal energy, or any other form, when we add them all together, we always get the same total value. This mathematical representation helps us solve problems and make predictions about energy behavior in various situations. Now let's look at some common energy transformations. Kinetic and potential energy continuously convert into each other, like in a swinging pendulum or a bouncing ball. Chemical energy transforms into thermal energy, such as when fuel burns in an engine. Electrical energy converts to light energy in a light bulb. Nuclear energy transforms into thermal energy in power plants. These are just a few examples of the countless energy transformations happening around us every moment. Yet in each case, the total energy remains constant. Let's examine a classic example, the pendulum. A pendulum demonstrates continuous energy exchange beautifully. When the pendulum is at the top of its swing, it has maximum potential energy and zero kinetic energy because it momentarily stops moving. As it swings down, potential energy converts to kinetic energy. At the bottom, it has maximum kinetic energy and minimum potential energy. Then, as it swings back up, kinetic energy converts back to potential energy. Throughout this entire motion, the total energy stays exactly the same, perfectly illustrating the conservation of energy. Let's summarize the key takeaways from this lesson. First, energy transforms, but the total remains constant. Energy continuously changes form, but its total amount never increases or decreases. Second, isolated systems conserve total energy. In systems where no energy enters or leaves, the total energy is perfectly preserved. Third, energy cannot be created or destroyed. This is the fundamental principle that governs all energy transformations in the universe. Understanding these concepts provides a foundation for exploring more complex topics in physics and helps explain the natural world around us.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.